Hey Dragons, we're going to learn about literal equations, and the good news is it works just like the equations we've been doing since school started. So we know that if we have a simple equation like this, we identify the operation. Well, this is subtraction of 7. Well, we'll undo the subtraction of 7, and we know that we're going to add 7. And what we do to one side of the equation, we do to the other. And so we create this 0 pair, this minus 7 plus 7 cancels. And it gives us x plus 0 is equal to the right-hand side, which is now 8 plus 7, which is 15. Now we don't have to write x plus 0. We know that that is simply x. And so we get our answer. This is good. A literal equation is one that has more than one variable. So I'm going to leave this one on the screen, and I'm going to bring in a literal equation, and I want to do a comparison, and I want you to notice that the process of isolating a particular variable is going to be the same as the problem you see on your screen now. So we now have an equation x minus a equals 8, and we're asked to solve for x. They will always tell you what variable you want to solve for. So I'm going to look at the x, and I'm going to ask myself, what's happening to the x? Well, there's this other unknown number called a being subtracted from it. Just like over here, we had a 7 being subtracted from x. Over here we have a number. We don't know what it is, but we're just going to roll with it. We've got a number being subtracted from x. What did I do over here when I had subtraction of 7? I did the inverse, which was addition of 7. I'm going to do the same thing over here, except I'm going to use the letter a. So minus a plus a will form a 0 pair, just like minus 7 plus 7. When I added 7 on the left, I added 7 on the right. If I add a to the left of the equation, I have to add a to the right. So now I get x plus 0 because this minus a plus a became a 0. But I cannot combine 8 and a. I don't know what a is yet. So I'm going to leave it as 8 plus a. So my final answer is going to be x equals 8 plus a. On this example, I was actually able to combine them because I knew what they were. Over here, I'm not. We're not going to worry about it. We're not going to lose any sleep over it. We're just going to write it down. So really, all we're doing is shuffling the equation so that a particular letter is by itself. Okay, why don't you give this one a try? Here's another example. Again, let's look at one with only one variable. X is being multiplied by 5. What is the inverse of multiplication? That's right, it's division. We'll divide by the coefficient of 5. And what I do to one side, I do to the other. So now I have 5 divided by 5 in front of the x, which is 1. And then I can divide 35 by 5 because I know those two numbers, and I can either do that in my head or in the calculator. And we know that 1x is the same thing as x. Keep that in mind. I'm going to now do a literal equation in the same process. So in this particular case, they tell us to solve for m. Okay, ask yourself, what is happening to the m? I have something squished right next to it, and that is implied multiplication. So m is being multiplied by x. What is the inverse of multiplication? Well, it's the same as it was over here. It's division. What is the number next to the letter that we want? It's the x. So I'm going to divide that side by x. What do I do to the other side? the same thing. Now, I've got a whole bunch of alphabet soup happening here. I can't get a numerical answer like 6 or 7 or whatever. I'm just going to have an answer that contains letters. So x divided by itself is 1. 1 times m is m. And I'm left with the fraction w over x. And that's what my answer is. M is equal to w over x. Okay, give this one a try. Now I'm just going to do more examples, and I want you to realize that I'm always identifying the variable, asking myself what's happening to the variable, and then I do the inverse operation to both sides, shuffling the letters around using math rules. I'm solving for A. A is being multiplied by C. The inverse of multiplying by C is division by C. What I do to one side, I do to the other. C divided by C, any number divided by itself, other than 1, is going to, other than 0, is going to be 1. So this C divided by C becomes a 1 in front of the A, and I've created this funny fraction G over C. I know that 1A is the same thing as a single A, so my answer is simply G over C. How about this one? Solving for M. M actually has two things happening to it. It's being multiplied by A, and it's being multiplied by 12. We're going to take this as one multiplication. M is being multiplied by 12A. Okay, what's the inverse of multiplication? Well, we've already mentioned that multiple times in this video and prior. The opposite or the inverse of multiplication is division. So I'm going to divide this side by 12A. It's a 2-for-1 special. 12 over 12 is 1, and A over A is 1. What I do to one side, I do to the other. And so I now get 1m, because remember the 12 over 12 is 1, A over A is 1, and I have this fraction. Now remember, you can reduce fractions, or this particular fraction, 4 over 12. 4 over 12 reduces to 1 over 3a, because 4 times 1 up here, and this is 4 times 3. So I can cancel a 4 out of each one of these. And there's your answer. Last example for me. Oh, got a whole bunch of alphabet soup happening here. This one says to solve for x. Now, hopefully you have taken a deep breath and just say, hey, these are just unknown numbers. X is being multiplied by m. Okay. If I want x by itself, I need the inverse of multiplication, which is division. So I'm going to divide by the letter in front of or next to the x. What letter should I divide by? That's right, m. And if I divide this side by m, what do I do to the other? Okay. Now, what is m over m equal to? That becomes my coefficient of x. And I'm left with this funny looking fraction. I don't know what the value of any of these letters are, so I'm going to relax and say n p over m is what is equal to x. All right, give this one a try. Try this one. Getting good at this. Go ahead and try this as well.